Hi guys, so my name is Raj Kapoor Singh. So I will be your trainer for this full PCI training course. So this is the introductory slides where I'm going to cover what are all the topics that I'm going to cover. But before that, here's a bit brief about myself. So I have a total of 12 years of industry experience, and I have industry experience of 7 years in the PCI. So I have worked earlier with the companies like Nvidia, Intel, Broadcom, and Cadence. So what are you going to get from this training, from this PCI training is in this full PCI training, you will get the video lectures for video lectures on the PCI Gen 1, Gen 2, Gen 3, and also on the several parts of the PCI Gen 5. And so also along with this training, we will be also giving you the presentations, PPTs as in which corresponds to each video lectures. And we also have prepared and created some more, study materials on the PCI that will be also shared. Going to next slide. Uh, okay. Who are the target audience for this PCI training? So, the any VLSI aspirants who are looking to foray in the VLSI industry, they are our target audience. Other than that, the college students who have background in the computer science and electronics and willing to learn PCI, so they are also our target audience. And the working design verification engineers who are willing to learn, so they are also our target audience. Art designers as well as the firmware engineers looking to learn the PCI. Okay, so why one should learn the PCI? So the reason being, this is PCI is one of the fastest serial communication protocol available in the market, and PCI is a niche skill set. Okay, and having a PCI skill set in your resume, it actually puts you ahead of the competition. And there is always a good demand of the skilled PCI engineers in the market, and the demand is actually going to increase in the near future. And other than that, if you are already working in the VLSI industry, and if you grab the skill in the PCI, it has this skill set. If you know this skill set, actually you can fuel this can actually fuel your growth in the VLSI industry. So, okay, many students have asked earlier, right? Earlier, what are we going to give them the, PCI test bench course or test cases? So, just want to be very clear with this training, you will not be getting any test bench or the test case code. Okay, certificate. So I mean, several students have reached us who are like looking to foray into the VLSI industry, whether after doing this training they will be getting certificates or not. Yes, the certificate you will be getting certificate, but after you complete the course, there will be a small test conducted, and based on the how you perform in the test, the certificate will be awarded. So let's move to the what are all the PCI training topics I'm going to cover. So okay, so the this full topic is divided into 18 sessions. I will be going through what are all the subtopics I have covered in each session. So starting with the session one. So this is the how the PCI Express came into picture. So session one covers the PCI X introduction and architecture. What are the drawbacks of the PCI and PCI-X, and what are the limitations of the PCI parallel bus, and also what caused us to move from the PCI parallel bus to the PCI Express, which is serial protocol. So this is covered in the session one in the video lecture one. So in session two, I'm going to cover the PCI architecture overview. So it introduces what is PCI, okay, and how the packet flows from transaction layer to physical layer. Full data packet flow is explained. Okay, so this full flow is explained in the session two. And in session 3, we are explaining the PCI configuration. PCI config, we have 4 KB of configuration space. So that is explained over here. So we are explaining here what is PDF, what is the PCI compatible space, extended configuration space, single host and multi-host systems, configuration request, type 0 and type 1, and also the enumeration. In session 4, we are going to explain you the address space and how the transaction routing happens. And the subtopics covered in this session are base address registers, bar registers, type 0 header and type 1 header, bar configuration in type 1 and type 0, base and limit registers in the headers. This is applicable for the type 1, of course, and registers used for the address routing. In session 5, we are going to explain you how you identify how actually the TLP routing happens, and how you identify what kind of TLP it is, how many types of TLP is there. Okay, so we are going to explain you the header format, type, field encoding in the TLP, basically the full TLP header, different types of TLP routing, header format of the TLP, 3D word and 4D word, memory request TLP format, and full flow through the layers, how the memTLP, starts from one, application layer of, root port, and it reaches to the, application layer of the uh, link partner. Session 6, in this, we are going to explain you the flow control in the transaction layer. The topics that I'm going to cover in this are flow control buffers and credits, flow control initialization. In this, we are also going to discuss the data link layer, control management state machine, DLCM SM state machine, and what is the full flow, or how the this DLCM state machine works. And in this session, in this same session, I have also covered the quality of service, which is like, actually it is related to the traffic class. So I'm going to explain here what is the traffic class and what are the virtual channels, and what do you mean by TC-BC mapping, and why do we need that. And apart from this, I've also covered what is the port attribution. Okay, so this will be covered in session 6. Moving to session 7. So transaction ordering. So as for most all the transactions have some traffic class. So there is some ordering rules defined in the PCI spec that I'm going to discuss in this session. Apart from that, I'm also going to discuss the data link layer. I'm also going to cover some topics of the data link layer. The topics that are going to cover are the data link layer packet format, what are the different types of DLLPs and their functionality, and what are the difference between the TLP and DLLP, ACK and NAC protocol using DLLPs. Moving to session 8. So session 8 is divided into two parts, session 8A and 8B. So in the session 8A, I'm going to cover the physical layer, logical part, Gen 1 and Gen 2. So this is generally the transmitter part of the physical layer. So here I'm going to cover the how full physical layer overview, transmit logic, how the transmitter packet is coming to the physical layer, how the byte striping, scrambling, encoding, and serialization, and the differential driving is happening. Full flow is covered over here. So, this is the transmit logic overview covers this, and also we have receive logic overview, how this packet is received at the receiver end, and uh, how it is decoded at the receiver side. And so this is covered in this chapter, in this session. In addition to this, I have also covered the packet format rules. Okay, packet format rules, as in, once the packet, how the packet, once you get the packet, we are adding some uh, characters like start, and if you go in the Gen 3, we are adding, framing. We are adding some of tokens which we call frames. Okay, so those rules are covered in this session. I have already explained mux byte striping, scrambler algorithm, 8-bit NV encoding, differential driving. So this is part of transmitter logic overview. So this is covered in this session. In the session 8B, most of the details covered are at the receive how the receive logic details, how the receiver decodes the packet. All the receive logic details are covered in the session 8B. So so in this, what we are covering is lane to lane DSQ, 8B, 10B decoder, byte and unstriping, descrambling, and how the physical layer handles the error in case there is a framing error. Okay, so session 9, physical layer, logical gen 3. So in this, I'm going to, session 8A and 8B was for the uh, Gen 1 and Gen 2, but session 9 is for the logical layer Gen 3. So here we have different kind of encoding. Here we have using 128 B and 130 B encoding. So it is explained in this session, and we have order sets introduced in the Gen 3. So all types of order sets are explained in this session, and the framing tokens, transmitter framing tokens, scrambling rules are also explained in this session. Okay. Session 10. In this, we are going to explain the Gen 3 physical layer receive logic. So what we have explained, differential receiver, Gen 3 physical, okay, differential receiver. I think it's the same Gen 3 physical layer receiver detail. So it's the same. And we have CDR logic, Gen 3 elastic buffer logic, how the elastic buffer is working, and the CDR is current CDR is it's CRD, should be CRD, sorry. It's current running disparity, so that logic is explained. How the elastic buffer at the receiver ends works, that is explained. Okay. And in this session, I'm also covering the electrical part of the physical layer. So I have covered the electrical overview. What is the how I will overview on the electrical sublayer, and transmit and differential transmitter and receiver, and the voltage margining. Session 11. So in this, okay, this is the continued session from the session 10. So again, this covers the electrical part. So here I'm going to discuss you what is the de-emphasis, equalization, and why we need the de-emphasis at the receiver end. There's and CTAP TX equalizer and the I test. What is I test and why we need this? All these things are covered in the session 11. Session 2. So here I'm starting the link training and link initialization and the link training. So basically the LT system part is covered in the session 12. So I'm covering here the order sets for the needed for the link training, TS1 and TS2. LT system states are covered, and overview of each LT system state. So and in this particular session, I'm covering the detect state and the polling state. Going back to coming back to session 13. This is also the anti-system part continued. Here I'm going to cover what is the link. Sorry, I'm going to cover the configuration state. And the configuration state, we have the substates that is also covered, like link number, lane number negotiation, and all the substates of the configuration state. And in this session, in this same session, I'm also covering the recovery state and the detailed recovery substates. Session 14, so in session 14, I'm covering the recovery idle is the one of the substrate of the recovery. I was not able to cover in the session 13, so it's covered in session 14. And apart from that, other LTS states like L0, L0S, L1, L2, hot reset, loop back, disabled, and what are conditions? What are the conditions? Uh, are required for the system to move from one state to other state, so covered in the session 14. Okay, coming back to session 15 here, this topic is actually error detection and handling. So in this, I'm covering the PCI error reporting, all types of error classes like correctable and uncorrectable errors, fatal error and non-fatal errors. Okay, what are the error checking mechanisms available in the PCI? Okay, errors checks by layer. So what I mean by this is at every physical layer, data link layer, and transaction layer, the errors are whether the packet is received correctly or not. The whether the packet is received correctly or not is checked. Okay, and so this is called checking the error at each layer. After that, I've also covered the error, all the registers. Once there is some error, we have capability registers AER is there. So what all registers are there in what are the correctable registers, non-correctable error status registers? All registers are also covered. So how the errors are reported, as in it is same as how the errors are reported. The errors are actually gets logged in the status register. So this is how the error is reported. So this is also covered. PCI compatible error reporting mechanism is covered, and the AER advanced error reporting is also covered. So it's a list of the capability structure. I have covered this in detail in this covered this all error handling and detection in this session 15. Session 16, in this session, I'm going to discuss what are the different types of interrupts available in the PCIe. So PCI Express. So the interrupts available so we are explaining MSI, MSIX, INTX. Okay, these are the two types of interrupt delivery method which I have explained it. Okay. And okay, what are the resets available? What are the system resets or the resets available in the PCI? So there are two categories of the resets. So there is one fundamental reset. Sorry, we have the resets available here are the fundamental resets, hot reset, and the function level reset. So these three topics are covered in this session. Chapter 18, session 18 is divided into two parts, 18A and 18B, and this session is on the power management. So here I'm going to explain what is power management and why do we need the power management, system power management states, and the device class specific power management specifications, and how your LTE system gets affected when you are the device is initiating the power management when a device is initiating the, let's say, low power state. And I have covered here in detail what is ASPM, active state power management, how and also how the software can initiate the power management. This is covered in this session, and the PME message. That's it. Thank you. So these are all the topics that will be covered in this full PCI course. Thank you.